Let's start. So, there are two testing techniques. One is the whiteboard testing. One is the blackboard testing. Whiteboard testing means the person who is performing the testing can easily read all the line of codes and can easily check if the instruction that is being used in the application development is it correct or is there any mistake in that. He can correct it or update it. That's why we call it whiteboard testing. It means the person who is performing testing has clear view of all the line of code that will be used in application development. Whereas blackboard testing means, as the name specifies, black means nothing is visible to us. So the person who is performing the testing cannot uh, read or update the line of code that are being used for application development. So how he can go for the testing then? The testing can be checked with the help of the output that is being performed. So the person who performed the blackboard testing gives some input and will check whether sorry the output is as per input or not. If the output is as per the input, so it means the testing is positive, and if the output is not appropriate as per the input, it means some error might be there in the testing, in fact in the application development, and the developer later on can update the line of code that are being used in application development. So let's start with the whiteboard testing. Whiteboard testing is testing that takes into account the internal mechanism of system or component. Internal means all the line of code that we have used in application development, or all the functions that are being used for the application development. That is come the internal mechanism of system or components. So the person who perform whiteboard testing can take into account the internal mechanism of system or component. So using the whiteboard testing technique, the software engineer can design following test cases. So various test cases are being designed by the tester who tests the application. So use independent path within the module or unit. So whiteboard testing can be performed by using all the independent path, by which path or by which functions we have go first, second, third, fourth, and final function that is being used to get the output. Second testing technique can be uh, exercise logical decisions uh, on both true and false side. So if we put some if condition over there, we have to check the true side. If the condition is true, are we getting the correct output? And if the condition is false, still we getting the correct output. And finally, exercise internal data structure to ensure the data validity. So let's start one by one. So first is the whiteboard testing technique, that is the statement coverage and branch coverage. So what do you mean by statement coverage? Statement coverage means that all the statements, all the line of code that we have written on the application development, we check each and every statement one by one. So as the name suggests, is the method to validate that each and every line of code is executed at least once. So because we have to check each and every line of code, that it means we have to execute each and every line of code at least once. So that after executing each and every line of code, we can check that every line of code is giving the executing correctly. No one is giving a bug error. So that's why we go for the statement coverage. That is a method of validating that each and every line of code that is being used in application development is executed at least once. Okay, how it's performed. Let's say that I'm having an application of input A and B. C is equal to A plus B. If C is greater than 100, then print it's done. So how the statement coverage will be done? Uh, Only one test check case or on all line of code. Test case one is that I input the value of A as 40 and input the value of B as 70, and then check all the line of code will be executed. Now the question arises: is that sufficient? So if the value of A is 40 and value of B is 70, then uh, You can see C will become 110, and as C 110 is greater than 100, I will get the output. Yes, I will get the output that it is done. So if I give the input A 40 and B 70, uh, then C become 110. As per condition, 110 is greater than 100, it become true. And when it is true, it will give me the output that print it is done. So my question arises, is that sufficient? Uh, do you think that is that sufficient that my application is correct? No, not yet. Let's say I take a case number two, that the value of A is 33 and value of B is 45. So if I put the value of A is 33, B is 45, then the value of C will become, you can say, 78. So 70 is greater than 100? No, is false. But in the line of code, there is no statement if the condition is false. So if the condition is false, there is no statement that give us the output. It means we get nothing if we give such type of value. It means our application is not fully developed. You will not get any error in it, but we will not get the output of it, in fact. So if you cannot get the output of it, it means we have to change some line of code over there. So in test case 2, the A is 33, B is 45, because statement coverage will only cover the true side. Only cover the true side for pseudocode. Only one test case would not be sufficient to test it. So only one test case is not sufficient. We have to go for the both test cases. One test case if the condition is true, and one test case if condition is false. So as a tester, we have to consider negative case as well. So because the value of A 33, B value of B is 45, this becomes C is equal to 78. Now in this case, as per this line of codes, C become less than 100. So there is no operation we are performing in this line of code that if the value of C is less than 100. So it means that when we execute each and every statement one by one, we find that there is some logical mistake in our application. The logic is that if the value of C is less than 100, it means we will not get any output for that. So how we can cover it? We can cover it by writing such type of code over there, that if AC is 100, if C is less than 100. So this become the uh, full expression of this. So second is the branch coverage. So we make some branches over there. What is branch coverage? Branch is first branch if it is true, second branch if it is false. So branch coverage is testing the method which when execute ensure that each branch from each decision point is executed. So in this case, we're having only two branches. One is true and one is false. So we will take only two branches over here. Hence, the maximum coverage we need to consider branch coverage, which will evaluate the false condition also. So in this case, we are having the some operation being performed on true condition as well as some operation being performed on false condition. Let's take the same input that we had done in the previous slide. The value of A is 55, the value of B is 45, then you will check it become 100. So still the value is not true, the value is false. So if the value is false, so what we have to do? So let's make some changes over here. I take it as 55. Fine. If I take it at 55, I take it as 55. If I take it at 55, then C will become 110. Now it's quite sufficient. Uh, Now the value of uh, C become 110, but is greater than 100. Yes, this become a true part. I get the answer. It is done. So it means that the true section is giving some output to me. Second is that I go for some uh, the condition that's giving me the false, activating the false condition. So again, I take the input of A as 25, B as 30, so it becomes C become, you can say 55. So 55 is less than 100. So if the value of C is less than 100, yes, there is some operation that is being performed if the value is untrue. So the value is false over here in this case. It means I will get the output that it is pending. So you can write any comment over there in the side. So it means the case one is for the condition if the condition is true, and case two go for if the condition is false. So with this, we can see that each and every line of code is executed at least once. Again, we have taken that two branches are being covered in this side. One branch if the condition is true, one branch if the condition is false, and we check each and every line of code at least once and execute each line of code. You can see when we are checking each line of code, when we check the value of a was 55 and value of b was 45. So we check over there that the value is still not true. So we update the value. It means we are checking all line of code at least once. So this is a very good example right now we have done that while this is called whiteboard testing because we can read all the line of codes. So during the reading line of codes, what I found that the value I have input over there still not covering the true statement. So I update the value in the a line of code. So it means that become again a very good example of the whiteboard testing. That if I am testing my application, so I can on the spot make some operation and check the results. So I on the spot change the value of b from 45 to 55. Now it's become 110 and it become two side. So it means this is what the whiteboard testing is, and how we can make the branches and how we can execute each line of code at least once, and by verifying the each line of code or executing each line of code exactly once, we can check whether the execution of each line of code give us the correct answer or not. So these are the very just few number of lines of code. If you are having a lot of line number of codes in thousands, 50,000 or 60,000 or so, to test all these line of code, we have to use the breakpoint. So breakpoint you can be put on this in such a manner that when you execute it, it gives you all the output, and whatever result it will give, it can be used for the next line of code that come after the breakpoint. So if you have a lot of number of line of codes to perform the testing, we can use the breakpoints, any number of breakpoints as per the size of your application. So this is branch coverage and statement coverage. So how we can go for the whiteboard testing that can be done. So you can give any other example in it. So if you let's say if we go for the while statement, uh, while using while we get a lot of conditions over there. If we get case statement, case one, case two, case three, case four, so the number of cases will become number of branches because each and every case arises some condition. So in the test in the programming side, we can use the case statement to increase the number of branches, and while statement can again also increase number of branches. So in such a way, you can cover the branches that you have used in your application development. Okay, that was the whiteboard testing, how you can test your line of code, and if you're getting some error in it, how you can update it. So in the this branch section, you can see there was no error, but still I was getting a wrong answer because the value of a and b was not greater than 100. So there's no that uh, error in the logical side, but there's an error in the input of that. So if I give the wrong input, still I getting the answer it's pending. It means something wrong in my input. So it means I have to go make some value that must be greater than 100. Okay, let's start further. Uh, Next is the Blackboard testing. So what is Blackboard testing is? Blackboard testing is that uh, whenever we are performing the testing, we are unable to uh, check the all line of codes, and without checking the line of code, we have to perform the whiteboard testing. So how we can done this whiteboard testing? Let's start. Sorry, Blackboard testing. Blackboard testing ignores the internal mechanism of the system or component and focuses only on the output generated in response to selected input and executed conditions. So it means the person who is performing the Blackboard testing just ignore the line of codes that are being used to design or develop the application. And as the tester is unable to access or read or update the line of codes, so how he can perform the testing then? Then the testing is being done that the tester focuses only on the output generated in response of selected input. Whatever input is being entered by the tester, according to the input, the tester will check whether the output that is being generated by the uh, application is correct as per the input and as per the input and the execution conditions that we have added into the line of code. So all the conditions are running well on the basis of input and on the basis of conditions. Is tester is getting the correct answer? If tester is not getting the correct answer, it means some mistake is there, might be in the development of the application. So the the tester will design a case study. In the case study, it will define that if I put such type of input, then I'm not getting the correct output. And if I writing this such type of input, I'm getting the correct output. So such type of case study is being designed by the Blackboard tester. So Blackboard testing attempt to find the errors in the following strategies: incorrect or missing functions that I input some values and I have used, let's say, four functions. One function is performing addition, one is subtraction, one is multiplication, and one is division. So I'm getting the answer of multiplication, division, and subtraction, but I'm unable to get the answer of addition. It means some function is missing that is not being executed. So, the after testing that or that application, the tester will make a report case study that all the three functions are running, but the one addition function is not running because I'm unable to get the output of addition function. Interface error. Interface error means I have used the function that I have two inputs A and B, and whatever I perform the addition function over there. So whatever the addition function I will get, whatever the value of addition will get, I will get the output of square of that addition. That become interface. Interface means I give the input, that input that is become parameter of a function that call addition. So addition function will make addition of the two inputs, and whatever value of that addition will get, it transfer that additional values to the next function, that is the square function, that it will make the square of that function. Let's say the value of a is 2, the value of b is 5, it becomes 7. So the function addition will send the 7 to the value, the next function square. If they are accepting the value, then I get the value square of 7 is 49. So the tester will get the 49. If tester unable to get the value 49 or some other value, it means there's some interface problem between the addition function and the square function. So interface means that various modules that are being used in the application development, they are unable to send some messages or receive some message from various modules. So the interface means that the passing of messages among the modules of function is not running correctly. Error in data structure or database access. So whatever data structure I'm using for running the data, whether it is array or whether it is some stack queue, whatever it is, so it is giving some wrong error in it. Let's say that I have used the stack. So if I want to add some new element, it instead of adding the new element at top of it, it's adding the new element at end of it. It means there's some mistake in the data structure that I have used, because the element is being added at the last end of it. It means the data structure should be queue, not a stack, not a stack. So it means there's some error in data structure also, or access of database, that I have given some command to access the some query of a data, unable to give the output of that query of data. That means some mistake is there in database also. Behavior or performance error, that I am getting incorrect error, or you can say you're getting a lot of time to get the output. If you're getting a lot of time to getting the output, it means some mistake is being done in the application development. Or if you're getting a wrong output, again there is some mistake in the performance of the application. Initialization and termination error, that the application is not giving me the answer, so it just hang out, not stopping, it just hang out, or without giving you the output, the application terminates. Without giving the output, the application terminates. That become the initialization or termination errors. So, student, this is a Blackboard testing. You can say errors we can find within a few seconds. Your the class will close, and we again restart the class. So kindly wait for a few seconds, and we restart the class again. Thank you.